Hello everyone. Today we are going to do few numericals of lesson 4 of class 10 from the science book, Time Crucial. And here we have our first question. Calculate the gravitational force between two bodies of mass 10 kg and 55 kg if they are placed at a distance of 2 meters apart. This is a very easy and basic question of the chapter course. If you know how to solve this question, later on you can do difficult question easily. That's right. What is given at first? Given there is two bodies of mass 10 kg and 55 kg. Then after we have to write mass of one object. Let us consider that is at m1 and 10 kg. Mass of another object m2, that is 55 kg. And now distance between them is 2 meters. Now simply we have to apply formula. F is equal to G m1 m2 by d square. By using this formula we can solve this question. Okay, usually the value of G, this universal gravitation constant, is given in question. In some cases if not given, then we have to write by ourselves. When the value of G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now simply we can substitute this value here. That is 6.67 into 10 to the power minus 11 into, now mass 1 is 10 kg. We don't have to convert because simply they are in the SI units, kg and meter. Mass 2 is 55, then we should divide that by 2. Okay, square of 2. Okay, now 6.67 into 10 to the power minus 11 into, now 10 into 55, what is that? Okay, that is 550. Now divide by square of 2, that is 4. Now simply you can divide 550 by 4 and you can multiply by this value. Let's do that one. 550 divided by 4, that is 137.5. Now 6.67 into 10 to the power minus 11 into 137.5, and at last we get value as into and that is equal to 9.171 into 10 to the power minus 9 Newton. Okay, that was our first question. Let's move to second question. Okay, I'll rub this one. If you have not written yet, please you can pause your video and you can write this. Here we have our second question. The mass of the Jupiter is 19 into 10 to the power 26 kg, and that of Earth is 6 into 10 to the power 24 kg. If distance between them is 6.29 into 10 to the power 8 kilometer, what is force of gravitation between them? Okay, simply in this context also we have to write given. At was given, here we have mass of Jupiter. Let us consider this as a M1, that is 19 into 10 to the power 26 kg. Then after mass of Earth, let us consider it as a M2 and is equal to 6 into 10 to the power 24 kg. Now distance between them is, that is D is equal to 6.29 into 10 to the power 8 kilometer. Now kg and kg, that is in SI unit, and we have to convert distance into SI unit, and SI unit of distance is meter, since we have to convert that kilometer into meter before doing numerical. Look, let's convert this into meter. Now simply what we have to do is 6.29 into 10 to the power 8 kilometer. To convert into meter we have to multiply it by 1000. Yes, 1000. That means that is 1000 means 10 power 3. You know that one. 6.29 into 10 power 8 and 3. The power get added. Okay, I have shown this so that you can clearly understood. 8 plus 3, and that is equal to 6.29 into 10 power 8, 19, 11. That is meter. Okay, simply we can write this 6.29 into 10 power 11 meter. Here 11. Let's remove this kilometer and write down here meter. I have converted this. Let's not write this one. Okay, now we have our formula for subtraction is equal to F is equal to Z M1 M2 by T square. As I have said earlier, we have to put value of Z by ourselves. If given in equation is okay, if not given, then we have to put by ourselves. And the value of Z is 6.67 into 10 power minus 11. Yes. Now look at mass. The value of M1 is, that is 19 into 10 to the power 26. Now into M2 is 6 into 10 power 24. And let's divide that by D square, that is 6.29 into 10 power 11 meter, that whole square. Okay. For simplification, let's put these terms at one side and power at next side, so that it can be easily downward. Let's say it can be easily calculated. Let's put this value 6.67 into 19 now. 19 into, that is 6 into, now 10 power, you know, in the law of indices from mathematics, minus 11, that is, yes, 26, plus 26 and plus 24. Yes. Now, okay, let's do the square of this. 6.29 into 10 power 11 square, that is equal to 3.956 into 10 power 23. Okay, now again what to do, let's multiply these terms. 6.67, 19 and 6. Now 6.67 into 19 multiplied by 6, that is equal to 760.38. yes, into now 10 power minus 11 plus 26 and plus 20. Let's add that. Okay, 26 plus 24, that is equal to 50, and minus 11, that is equal to 39. That means 10 power 39. Let's divide that by now 3.956 into 10 power 23. Yes, now like simply it is 10 power 23. The power 23 is, okay, if it goes to the numerator side, right, it will be subtracted. Now let's do that one. 10 power 23 is now 3.956 is remaining. Okay, now okay, 39 minus 23, what will be the value? That is, okay, 760.38 into, okay, 39 minus 20, that is equal to 16. That is 10 power 16. Now it's divided by 3.956. now 760.38 into 10 power 6. Okay, divide this by 3.956. okay, okay, now we get value as 1.92 into 10 to the power 8 Newton. Okay, here we have our answer. Now let's move to the next question. I think that is from section C or section B. Since few students have problems regarding that question, I am going to do that one. And question was like that, I think. Okay, next. What happens to the force of attraction between any two objects when mass of one object get doubled? Okay, at first let's consider, okay, mass 1 and two objects of m1 and m2, and distance between them is d. We need a formula to calculate the force of attraction between, okay, any two objects. F, okay, F1, let's consider F is equal to G m1 m2 by d square. Yes, initially when there is no change in mass, or let's say, and the force of attraction between any two objects, F is equal to G m1 m2 by d square. Okay, now let's consider this as equation 1. Okay, now what happened to force of attraction between any two objects when mass of one object get double? Okay, one of the mass of one of the object get double. Either it may be m1 or it may be m2. We are going to get the same result. Okay, let's consider. Okay, then mass become double. Okay, then how to make double? Simply multiply that by 2. Simply in second condition, yes. So that's fine. Second condition, the force of attraction is F2 is given by Z is equal to m1, m2 is double. That means 2 into m2. That is 2 m2 by d square. Yes. Now F2 force of attraction. That means second condition. Now we have here that 2 we can put here in front. Okay. 2 Z m1 m2 by d square. Simply that 2 is as it is. Now look at it, Z m1 m2 by d square from equation 1. Okay, f1 is equal to Z m1 m2 by d square. Simply we can substitute this value as f1. So now f2 is equal to 2 into, now look at here, Z m1 m2 by d square. That means Z m1 m2 by d square, that is equal to f1. Okay, then now therefore f2 is equal to 2 times f1. That means the force of attraction will become double. Simply the new force of attraction will become double, or let's say when mass of one object get double, the force of attraction also will get double. Okay, let's do next question. Okay, let's make some changes in question. Okay, what happened to force of attraction between any two objects when mass of one object is double? Let's not do that. When the distance becomes double. Initial condition, okay. In initial condition, the distance was not changed. Only simply mass was double, and it was one of the object. Now here mass remain constant and distance get double. Okay, simply. Now what happens to the force of attraction between any two objects when distance become double? Let's say like initial condition, as usual we have to write like this: F1 is equal to, when there was no change, Z m1 m2 by d square 1. When distance become double, now distance has become double, now we have to write F2 is equal to, okay, initial distance was d, now it become double. That means we have to multiply d into 2. That means distance become 2d. Okay, simply in the case of d we have to write 2d. Okay, Z m1 m2 by d square, in place of d replace that by 2d. Since there is square, we have to put bracket and there would be whole square. Instead of d, that is replaced by 2d. So now F2 is equal to Z m1 m2 by 2 to the 4, d square is d square, 4d square. Simply, okay, now here we can do like this: 1 by 4 into Z m1 m2 by d square. Okay, simply Z m1 m2 by d square is F1. That's why 1 by 4 into F1. Okay, therefore F2 is equal to 1 by 4 into F1. What does it mean? It means that the force of attraction decreases by 4 times. Like simply, the new force of attraction is just 1 by 4 of what? Initial force. And you also know that simply from basic concept, when the mass get increases, the force of attraction get increases, and when distance become them increases, then force of attraction get decreases. And same that is happening here. Okay, this was part 1, and in part 2 I will be dealing with a little bit complex numerical. Okay, see you again next time.